And here we are. We have our new unit on trigonometry. Trigonometry is one of those ideas that we are going to be looking at in grade 10, grade 11, and 12, and we're going to build on it every time we go. So it's really important that we've got a good fundamental grasp of what trigonometry is and how we can use it. So the first thing we're going to look at today is 2.1, called the tangent ratio. So when we're looking at trigonometry, we're basically looking at the study of triangles. So triangles, of course, have three sides and three angles. In this course, grade 10 math, we're only going to look at right angle triangles, where one of the measures is 90 degrees. So if I've got a triangle here, a right angle triangle has one of these three angles to be 90. And we indicate that 90 by putting a little box in the corner. So we know this is a right angle triangle. We can use the tangent ratio in order to solve. In a right angle triangle, or any triangle for that matter, there's a unique relationship between the legs and the hypotenuse. Now you may remember from grade 9 that the hypotenuse of a triangle is the longest one. So we've got two legs, 1, 2, and our longest side is called our hypotenuse. There are actually three relationships we're going to look at. The first one is called the tangent ratio. Here's the actual formula you need to understand how to use. And what we have here is tan of the angle. This is a theta symbol. It represents the angle that we're looking at. Is equal to the length of the opposite side divided by the length of the adjacent side. And right now these words don't mean much to us, but we will in a second. Now to summarize this, we would say that the tan of the angle is the opposite over the adjacent. So when you see this formula, what we mean is the opposite length of the opposite side divided by the length of the adjacent side. So when you are given a trigonometry question, first thing you have to do is label your triangle. There are three sides of a triangle. One of them we're going to call the opposite side. One of them we're going to call the adjacent side. These two are directly related to the angle. And then we also have the hypotenuse. The hypotenuse is going to be the longest side. And if you've got numbers on your triangle, you simply find the longest number to be your hypotenuse. Or it's the one that's across from your 90. And if we look at this little diagram that I drew up here, this was my 90 degrees. Across from the 90 degrees is my hypotenuse. Longest side, hypotenuse. So let's look at a basic question on how to use tangent. So what we're asked here is to find the tan of angle A and the tan of angle B. So I'm going to put angle A in red. So we got to ask ourselves, where is angle A? Angle A is in this top left corner. So this is going to be my angle. So once I have my angle, I need to start labeling the triangle. Here's angle A, so we need to find opposite, adjacent, and hypotenuse. This is 90. I go across the triangle to get to my longest side, hypotenuse, HYP. So is it the longest? Yes, this is 10, this is 8.6, this is 5, so it is my longest side. Now I have to label my opposite side and my adjacent side. Me personally, I like to label the opposite first. And what happens here is I find the angle I'm dealing with, angle A, and I go through the angle, across the triangle, to get to the opposite side. So this becomes my opposite. And my adjacent, then by default, would be up here. Now the adjacent side will also touch my angle. This is angle A, hypotenuse touches it, which is already labeled, and the adjacent touches it. So in this case it's 5. So I've labeled my triangle with hypotenuse, opposite, and adjacent. Then I got to pull out my tan formula. Tan of the angle, and I know the angle this time, it's A, so instead of theta, I'm going to write down A equals the opposite divided by the adjacent. So now I plug in what numbers I know. Here's my first variable, A, and I ask myself, do I know the value of that angle? Do I know how wide this angle is? I don't, so I'm going to leave it as A. Tan of A. Do I know the value of my opposite side? Well, I do. The opposite side is 8.6. Do I know the value of my adjacent? My adjacent is 5, so I'll divide this by 5. So now I come and try to do as much math as I can. And what can I do here? I can take 8.6 and divide it by 5. So the tan of A, which is what my question is, find the tan of A, is equal to 8.6 divided by 5. And I'm going to pull out my calculator here, and I'm going to go 8.6. Oh, I got too many decimals there. 8.6 divided by 5 equals 1.72. So I come in here and write down 1.72. And that's as far as I need to go right now. In a second, I'll take it to the final step, but the question here is asking find tan of A. Tan of A is 1.72. Now we gotta do the tan of B, and I'm going to switch to a blue pen for tan of B. Every time I start a new question, I have to make sure I relabel my triangle. So tan of B is now down here. So now labeling my triangle is going to change slightly because I'm changing my angle. Hypotenuse, well, that's still going to be in the same spot. It's still across from the 90, that hasn't moved. It's still my longest side, hypotenuse. But now my opposite, I start at angle B, go through the triangle. It's switched now. My opposite is now up here, and my adjacent is now on the side. So when I switch angles, my opposite and adjacent switch places. So I pull up my formula again. Tan of B is the opposite over the adjacent. Again, I plug in what I know. I don't know a value of B, so I'm going to go tan of B is equal to my opposite is now 5, and my adjacent is now 8.6. So I look now at what math I actually can do. I can't do anything with a tan of B because it's an unknown, but I can take 5 and divide it by 8.6. So I'm going to go to my calculator here, clear my screen, and I'm going to go 5 divided by 8.6 equals, and I've got a huge number here. Now for accuracy, when you're working inside your work, if you just round properly to the 4th decimal place, so 5814 or 3, and then you ask, do I round the 3 up or do I keep it as 3? Well, my 9 definitely rounds the 3 up to a 4. So I'm going to have 0.5814, a properly rounded answer. So tan of B is 0.5814. Final answer. Tan of A, tan of B. Now in most questions we are going to take this one step further, but right now we just want to get used to labeling our triangle and figuring out the tan of an angle, whether it's A or whether it's B. Let's flip our page. And here's where we'll take it one step further. I'm no longer asking for the tan of the angle, but I want to actually figure out what the angle really is. Find the angle. So again, do these the same way. We're going to go with F first. I'm going to pull a red pen out and find angle F right here. Once I've found the angle, I start labeling. Hypotenuse. 90, I go across, hypotenuse. Opposite. Angle, I go across, opposite. And adjacent. Touching the angle, adjacent. So now I've labeled this, I'm going to pull up my formula. Tan of F equals opposite over adjacent. Plug in what I know. I don't know my angle, so I've got tan of F equals, my opposite is 4 and my adjacent is 6. So I'm going to go to my calculator now. I'm going to take out decide what 4 divided by 6 is. Clear my calculator. 4 divided by 6 equals 0.6666666. So I'm going to round that appropriately to tan of F equals 0.6667. Okay, so now I need to take this the next step. I want to get F by itself. So I have to do the opposite of tan. Just like if I was dividing, I'd do the opposite, I'd multiply. So what is the opposite of tan? Well, it's the inverse of tan. So what I have to do is go to my calculator, and you can see that I've got sine, cos, and tan on my calculator. And these buttons will be found in every single calculator. But I don't want to do the tan of my number. I want to do the inverse of tan. So on your calculator, you have to find a button, and the button is different for every calculator. It might say second F, second function. It may say inverse, INV. It might be an upside down V. There are a whole bunch of different possibilities. So we could be having the second function, could be an inverse, it could be a upside down V, depending on your calculator's brand, depending on which button you hit. I'm on the internet and I'm using Meta Calculator. And on Meta Calculator, it's the invert button here. So I'm going to have my display still filled up with all those 6s. I'm going to hit the invert button, and when I do that, you can see a -1 comes up to all these 3 buttons. So I want to do the inverse of tan. I do the -1 of tan, and I got to hit equals. The angle now is read right here, 33.69. I'm going to round that properly to 1 decimal place, so 33.7. Come back and F is 33.7. So my unit here is going to be a degrees, a little degree symbol, little circle above the 7. So what were the steps to get this? I had my 0.666 in my calculator. I hit my second function or inverse button, and then I hit tan. This process should give me 33.7. Now there's a chance that you're going to get an error button. Some calculators are going to ask you to do things in a little bit different order. They'll ask you for the second function button first, then the tan, and then your number. So depending on how your calculator works, determines the steps you need to get 33.7. Now it's really important that you use the same calculator every time so that you know exactly the steps you need for that particular calculator. Okay, let's find angle E. I'm going to switch to a blue. Angle E is up here. So again, my hypotenuse stays the same. I come through the angle to get to my opposite, leaving the angle, the side here, to be my adjacent. Same steps, pull up my formula, and you should write the formula down every time just so you get familiar with it. Oh, tan of E is the opposite over the adjacent. I don't know E, so I've got tan of E. My opposite has now become 6, and my adjacent has become 4. So tan of E is going to be 6 divided by 4. Let's go to my calculator, clear it all out. 6 divided by 4 equals 1.5. So tan of E is 1.5. I'm looking for my angle, so I'm going to say E is going to be the inverse tan. Switch back to the calculator. I've got 1.5 in my display. I've already hit the second function button, and I hit tan. I think I hit it twice there. So I will clear that out. I'll have 1.5 equals 56.30. So I'll round that properly to 56.3 degrees. Okay, let's scroll down a little bit. A few terms that we have to be familiar with. The angle of elevation and the angle of depression. So the angle of elevation is the acute angle inside the triangle made of the horizon. So the angle of elevation will always start off flat, and it'll make an acute angle that goes up. Right here, angle of elevation. Start off flat and go up. This will usually be made within my triangle. There's my triangle right there. Angle of elevation. Flat, moving up. Now the angle of depression is a little bit different. It's the acute angle outside of the triangle made of the horizon. The angle of elevation will always, or depression will always start off flat and go down. There's the angle of depression. Now most of my triangles, however, will go down and look like this with my 90 right here. So the angle of depression is usually found outside of the triangle. But that's no problem. That does help us still. If I know the angle of depression is 50, well, what's the inside angle? Well, you have to realize that by drawing these two, I've made 90 degrees. So if the whole thing is 90 degrees, and this part's 50, how much is this? 90 minus 50 gives me 40. So a quick calculation for using the angle of depression will allow me to figure out the angle inside the triangle. Okay, let's look at this really quick. A tree is 15 meters tall and casts a shadow of 23 meters. Determine the angle of elevation. Okay, well this is an example of how we get a word problem, and we need to now apply trigonometry. I am going to ask you to do one little thing though. I'm going to ask you to change the angle of elevation to the angle of depression? I like this question a little bit better. Okay, so we know we're dealing with trigonometry here, so we gotta have a triangle. So let's draw one. Here's my triangle right here. Okay, so now we're going to apply the actual question to my triangle. So a tree is 15 meters tall. Where on my diagram would I see a tree? Well, usually trees go straight up and down. So here's my tree. Little palm tree. And here's my tree. And it's 15 meters. And it casts a shadow of 23 meters. Well, where do you see a shadow? Well, you see it on the ground. So this is where my shadow would fall, 23 meters. A common mistake is to think that the shadow would be the diagonal line. Well, that's technically where the light is being blocked, but you see the shadow and you could measure a shadow along the ground. Determine the angle of depression. So the angle of depression starts off flat and goes down. Well, where do you see this on my diagram? Well, you see it right here. Horizontal and go down. So I want to calculate this. This is my unknown. It's outside of the triangle. So what I have to do is I've actually got to calculate this angle right here. Once I have that angle, I take that away from 90, gives me the angle of depression. So this is, moved there by mistake. So this is the angle. I start labeling hypotenuse right here, opposite, and adjacent. So I don't know the hypotenuse, I know the opposite and the adjacent. I can use tan. Tan of the angle, and I don't have a letter there, so I'm just going to call it the angle, is the opposite over the adjacent. Plug in what I know. Tan of the angle, the opposite is 23 over 15. So I can work out 23 by 15 on my calculator. So I'll switch to MetaCalculator here, clear it out. 23 divided by 15 equals. Now from my last session, the inverse button was already pushed. Or I'll go write this number down actually, 1.5333, rounded to 4 decimal places. So tan of the angle equals 1.5334, and my angle is going to be second function tan 56.88, rounded correctly to 56.9. Now of course that's my angle in the triangle. The angle of depression, 90 minus 56.9 equals, let's go to the calculator, clear it out, 90 minus 56.9 equals 33.1. And there we go. Now we can go to our textbook, or before we do that, I want to mention one last thing in my calculator. Your calculator is going to have 3 different settings: radians, degrees, and gradients. If your calculator is not set to degrees, then you're going to get different numbers when you do the sine, cos, and tan. Regular addition and subtraction you're not even going to notice, but when you go to the trigonometry, you got to have it up. So on your calculator, you've got to see the DEG button, or perhaps it's just a little D, but you don't want to see an R or a rad. You don't want to see a G or a grad on your calculator. If it is, you need to learn how to switch your calculator to degrees. So now we got our calculator work, page 75. Let's go 2 A's, 5 B's, and 1 from the C's.